Okay, so we left off in section 1.3. We had just finished simplifying fractions using prime factorization. So we're going to go ahead and pick it up from there. So the next thing we're going to talk about is multiplying and dividing fractions. Okay, so the standard definition for multiplying is that if I have a over c as a fraction, and I want to multiply that, let me change that. Should be a over b, not that that really matters, but times another fraction, c over d. The rule is we multiply the numerators together, and we multiply the denominators together. So you do not need a common denominator or anything like that to multiply fractions. You simply multiply across the top, and then you multiply across the bottom. You do have to, however, state that b cannot be 0 and d cannot be 0, because we can't end up with 0 in the denominator when we multiply those two things together. So let's go ahead and take a look at an example or two. I think this will be example 3, following what we were doing. So we're going to multiply 2/15 times 5/13. Okay, so one of the reasons that we do the prime factorization is so that you start to get the idea that certain things on the top, if they're in completely factored form, can eliminate certain things on the bottom. So one thing I want you guys to see is we can certainly multiply the top straight across. There's no problem with that, and we would get 10. The problem is, if you had to do this without a calculator, 15 times 13 in the denominator, not an easy thing to do in your head. You could probably figure it out if you wrote it out and did it on paper long ways. But there's a slightly easier method to do this. And we're going to use the idea that we did before of the prime factorization. What I'm going to do, instead of actually multiplying the 2 times the 5 and getting the product, I'm just going to write it as 2 times 5. That's my numerator. The denominator has 15 times 13. 13 is already a prime number, so I can't prime factor it. But 15 can be prime factored. If you guys remember that, that would be 3 times 5, both of which are prime factors. And what you should see is that I have something in the top and something in the bottom that's exactly the same. So those factors are going to divide out the 5's, which leaves us only in the top with 2. And the denominator, 3 times 13, is just a little bit easier to do without a calculator if we needed to. 3 times 13 would be 39. And that is multiplying those two fractions and simplifying to the simplest form. And remember, the simplest form must mean you have no common factors left in the numerator or in the denominator. All right, now I'm actually going to show you a slightly different way to do a problem like this when we get to a later example. All right, example 4. I'm sorry, before we get to example 4. So that was multiplying. Again, basic concept, multiply straight across the top, multiply straight across the bottom. If you can prime factor, it'll make it easier to reduce as we go. Otherwise, you're going to end up with some really big numbers, and then you're going to have a harder time reducing it. So now let's talk about the idea of dividing. So dividing. The general idea for dividing, and you've probably heard this before, and try and explain why it works, is that if I have A divided by B, and I want to divide a fraction, C over D. The rule is you keep the first fraction, and whenever we divide fractions, you actually multiply by the second fraction's reciprocal, which would then be D over C. And then you multiply straight across the top, and we'll get AD over BC. So the question might be, why is that? Why does that work? Why am I telling you this rule, which you've probably heard before, but I've never really understood why that actually works? Okay, let's try and take a simple concept to explain this. So here I'm going to have a whole pie and another whole pie. And what I'm going to do is I'm going to cut those pies in half. So what you should see is that I have two whole pies cut in half. So if I was going to take two pies and divide it by, divide it by a half, what this is really asking us is how many halves go into two whole pies. So 2 divided by 1/2, it means how many halves go into two whole pies evenly. Well, if you look at it, 1/2, 2 halves, 3 halves, 4 halves. So the answer to this problem should be 4. And now let's see that that actually works. Let's create fractions out of both these things. So that would be 2 over 1 divided by 1/2. If we follow our rule, the rule says keep the first one the same and then multiply by the reciprocal of the second one, which is 2 over 1. Multiplying straight across, we get 4 over 1, which is 4. So again, the idea is when you're dividing fractions, you're asking yourself, how many times does the second fraction go into the first fraction? Well, a half goes into 2 4 times. As you can clearly see, there was 1, 2, 3, 4 halves. And that made up our 2 whole. So this is the idea anytime we divide fractions, and that's kind of why it works. It's not a total mathematical proof, but hopefully it gives you something concrete that you can actually see, oh, okay, that makes sense. All right, now we'll do our fourth example. Example number 4. We've got actually a few parts to this one. We're going to do 4/5 divided by 5/16. 4/5 divided by 5/16. We're really asking ourselves how many 5/16 go into 4/5. That one's not as intuitive to see, and it's really difficult to draw pictures of, so I'm not going to worry about trying to picture there. But we are going to follow the rule, which says we'll keep the first one, multiply by the reciprocal of the second one. Now we multiply straight across the top and straight across the bottom. First of all, I can see that this is not going to be able to reduce because 4 and 16, while those are not prime, do not have any 5s in them. The denominators are 5s, so there's nothing that's going to reduce. So we just multiply across the top and across the bottom. 4 times 16 might take you a few seconds, but that's 64. And then 5 times 5, we should all know, is 25. 64 25ths is the solution to that problem. Letter B. 7/10 divided by 14. So we're asking ourselves, how many times does 14 go evenly into 7/10? considering 14 is a big number, it's going to go in a really small amount of times into 7/10. At least you would think so. So let's see. Let's follow the rule. First of all, it's still a fraction divided by a fraction. We just have to create a fraction out of the second one. So we're going to make 14 over 1. Now I can write a reciprocal. So keep the first one, multiply by the reciprocal of the second one. Okay, here's where I'm going to show you guys a little something different. This is a process which is called cross-cancellation, and if you can see this, and if you're good at your reducing, then you can use this. If not, go ahead and go to the process of prime factorization. You're still going to end up with the same thing. Cross-cancellation says that when we're multiplying fractions together, it doesn't matter where the numerator and denominator are, you can still cancel some stuff out or reduce. So, in this case, what I see is that I have a 7 here. Whoops, it's not coming in red. There we go, 7 there. Uh-oh. 14 there. I know that 7 divided by 14 is 1/2 because 7 goes into itself 1 time. 7 goes into 14 2 times. Okay, I can't do anything with the 1 and the 10. I don't have anything left over to cross cancel. So now I've got 1 times 1 on top, 10 times 2 on the bottom. We get 1/20. So 7/10 divided by 14 is 1/20. Okay? One more. 3/8 divided by 3/10. All right, once again, the first thing we do when we divide fractions is to multiply by the reciprocal of the second fraction. 3/8 times 10 over 3. Now, I'm going to use my process of cross cancellation. I see that 3 and 3 are on the top and the bottom. Those divide out. 3 goes into itself, 1 each time. I've got a 10 and I've got an 8. I know that 2 goes into both of those. 2 goes into 8 4 times. 2 goes into 10 5 times. Now all I have left is a 1, 5, 4, and 1. None of those things are going to have any cross cancellations. So I can multiply straight across the top, multiply straight across the bottom, and I've got 5/4. So 3/8 divided by 3/10 is 5/4. All right, that is multiplying and dividing fractions. Personally, I think those are the two easier methods to use. Now we're going to get into adding and subtracting. Adding and subtracting fractions with common denominators. And you have to have a common denominator to add or subtract fractions together. That's because, again, I'll kind of use my pie. There's a pie that's split into halves. That's supposed to be split into equal thirds. If I wanted to take this half of my pie and I wanted to add it to 1/3 of that pie. So what I'm doing is I'm taking a half and I'm adding it to a third. Okay, a lot of people have the misconception that you add the tops and you add the bottoms together and you would get 2/5. Well, one thing's for sure, if I have half of a pie and I add a third of a pie, I should have definitely more than a half of a pie. 2/5 is less than half of a pie, so there's no way that this works. That is not right. In order for us to do this, we have to actually cut these pies into something where the total amount on the bottom is exactly the same. Therefore, we're using the equivalent amount of space. What do I mean by that? So let's cut the first pi. Well, first of all, you should be able to look at 1/2 and 1/3 and know that the least common denominator between those two denominators is 6. It's the smallest number that both 2 and 3 go into evenly. So if I cut these pi's into equal sixths, okay, now I have that pi cut into sixths, and I'm going to do the same thing with this pi. I've now cut the pi's into equal sixths. They both have exactly the same amount of slices. And if you look over here on the left pi, 1, 2, 3 of those sixths. Over here, I've got 1, 2 of those sixths. I can now add those together and say that I have taken a total of 5/6 of a pi. Now, how would I come across all that? How would I get to that stuff right there? The idea is, remember that you can multiply any fraction or any number by 1 and it doesn't change the fraction. So what I can do is I can figure out what my common denominator is, which again we said had to be in sixths. And the reason I know that is because 2 and 3 both go into 6 evenly. It's the smallest number that they both go into evenly. So I can look at this 2 over here on the left-hand side and say, what would I have to multiply by the 2? Well, I'd have to multiply it by 3. But I can't just multiply a denominator by 3 because now I'm changing the fraction. I also have to multiply the numerator by 3 because 3 over 3 is 1, and I'm not changing the fraction. Now I'm just going to change the way it looks. And lo and behold, multiplying 3 times 1, 3 times 2, I get 3/6. I would have to do the same idea with my 1/3. What would I have to multiply by the 3 on the bottom to get 6? I would have to multiply it by 2. But I can't just multiply the denominator by 2. I must multiply the numerator by 2, so it's 2 over 2, which is 1. And that's going to give me 2 on the top and 6 on the bottom. And now I've created equivalent denominators. Okay, so that's the concept of why we have to have like denominators, and then we're going to go into more on how to make like denominators if they're not common already. All right, first example of this section. This is actually example 5 overall. All right. If I have 2/7 and I want to add 4/7, the denominators are the same, which means both of whatever these things are cut into exactly the same amount of pieces. So if I have 2/7 of something and I add 4 more sevenths of something, I should end up with 6 total sevenths, 6 out of the 7 pieces. If I have 3/10 and I want to add 2/10, well, if I add those together, if I have 3 out of the 10 pieces and then I add 2 more out of the 10 pieces, I should have a total of 5 out of the 10 pieces. But 5 out of 10 reduces. Hopefully this is one you can do without the prime factoring thing. 5 out of 10 is a half. Likewise with subtraction. If I have 9 out of 7 pieces, which is interesting because that's actually more than the whole, and I take away 2 out of the 7 pieces, I end up with 7 out of the 7 pieces, or in this case, 7 out of 7 would just be 1 whole. Okay, one more. If I have 5 out of my 3 pieces and I subtract 1 out of my 3 pieces, I should now have left 4 out of my 3 pieces. Okay, so I'll actually have more than a whole left over. Okay, so now let's move on because those are the easier ones. Let's move on again to the idea where we have something where the fractions don't have common denominators. So the first thing we want to talk about is just writing equivalent fractions. So we simply want to write 2/5 as an equivalent fraction with a denominator of 20. So what that's really telling me to do is I want to make 2/5 equivalent or equal to something that has a denominator of 20. Well, the easiest way to think about this is what would I have to multiply on the top and the bottom of the left fraction of 2/5 so that my denominator becomes 20? Well, what would you have to multiply by 5 to get 20? You'd have to multiply it by 4. And if I multiply the denominator by 4, in order to not change the fraction and keep it equivalent, I have to multiply the numerator by 4. So if that's the case, since my 4 times 5 on the bottom gives me 20, 4 times the 2 on the top is going to give us 8. So my equivalent fraction to 2/5 is 8 over 20. It's not reduced, it's not simplified, but they are equivalent fractions. Okay, and again, the reason that we do this is so that we can figure out how to add and subtract fractions with not like denominators. And example 7 will have those. So 2/5 plus 1/4, and notice I left space there on purpose. We need to add these two things together. They don't have common denominators, so they're not cut into exactly the same amount of pieces. In order to do that, we need to create something where we have them cut into the same amount of pieces. Well, the least common denominator, called the LCD, is the smallest number that both 5 and 4 go into evenly. In this case, it just happens to be that when you multiply 5 times 4, 20 is the smallest number that they both go into evenly. That's not always the case. You can always find a common denominator by multiplying the denominators together. It might not, however, be the least common denominator, and we'll see that in a second. In this case, it is, though. So we're going to take and multiply whatever we need to on the bottoms and the tops to get 20 as a denominator. What would you have to multiply by the 5 to get 20? Well, that would be 4. But again, you can't just do the bottom, you have to do the top. And then the 1/4 you would have to multiply by 5 and 5 on the top. Now, multiplying straight across the top and straight across the bottom is going to give us 8 over 20 plus 5 over 20. Now we have everything cut into equal pieces of 20, so we can add them because it says that I have 8 out of my 20 pieces plus 5 more out of my 20 pieces. That means I have a total of 13 out of my 20 pieces. So 2/5 plus 1/4 is the same as 13/20. All right, letter B. 19/6 minus 23/12. So 19/6 minus 23/12. Definitely not the same denominator, at least not yet. Now I did say before that you can always get a common denominator by multiplying the two denominators together. So we could do 6 times 12. There would be no problem with that. It's just going to give us a really big number. And if you did that, you'd have to multiply the left fraction by 12 over 12 and the right fraction by 6 over 6. You're going to get some pretty big numbers out of that. However, what you have to look at is the denominators have a smaller number that they both go into evenly. Well, 12 goes into itself one time. 6 goes into 12 2 times. So they both go into 12 evenly. That means 12 is my common denominator. I don't have to do anything with it. What I do need to do, however, is change the 6 into a 12. In order to do that, I'm going to need to multiply the top and the bottom of the left fraction by 2 over 2. Now I'll have common denominators once I multiply these things out. So let's see, multiplying the top, I'm going to get 2 times 19, that's 38 over 12. And the second one, like we said, already has 12ths. So we're good there. Now I have 38 twelfths, and I'm going to take away 23 of those 12ths, which should leave me with 15 of my 12 equal pieces. 15 over 12, however, does reduce. Again, you could prime factor this, or if you can see that 3 is a number that goes into both the top and the bottom evenly, 3 goes into 15 5 times, 3 goes into 12 4 times, so my reduced fraction is 5 over 4. So 19/6 minus 23/12 is the same as 5/4. All right, and this can be extended to 3 fractions or 4 fractions or however many fractions we have. If I have a half plus 17 over 22 minus 2 over 11. The idea is now we're looking for what is a common denominator for all 3 fractions. Well, I'm hoping that you guys can see that 2 goes into 22, 11 goes into 22, and of course 22 always goes into itself. So the common denominator here is 22. That means I'm going to have to multiply the 1/2 by 11 over 11 to get a 22 on the bottom, and the 2 over 11 I'm going to have to multiply by 2 over 2 to get that 22 in the denominator. So now let's multiply 11 over 22. The second one stays the same. It already had the 22. The third one now becomes 4 over 22. And then we add left to right. So 11 20-seconds plus 17 20-seconds would give us 28 20-seconds. And then we'll take away 4 of those 20-seconds, and we get 24 20-seconds. Both of those numbers are even, so we know a 2 can be divided out. 2 goes into 24 12 times, 2 goes into 22 11 times. So it looks like what we end up with is 12/11. Okay, hopefully you guys are still with me on this. All right, the concept of mixed numbers. First of all, what we need to know is mixed numbers are not used very heavily anymore. It's just not commonly done. Probably one of the most places you're going to see mixed numbers is maybe in cooking or something, 3 1/4 cups of something, or 1/2 cup or something. Or anyway, mixed numbers just aren't used very much anymore, but we'll deal with them because it's in the book, and we still need to talk about them. First thing is, mixed numbers are written, actually they're written, and this is just a pet peeve of mine, mixed numbers are more improper than improper fractions are because of the way they're written. If you see something that looks like this, we know that that's 3 1/2. However, really what that means is 3 plus 1/2. So the way we have it written, 3 next to 1/2 actually should indicate multiplication, which is technically written wrong. Because that really, the first one indicates 3 times 1/2, but we always have written it that way. So that's more improper than it is proper. But anyway, the mixed number is this one. In order to change a mixed number into an improper fraction, because we'll need to know how to do that. So if we think about it as 3 plus a half, we can write it as 3 over 1 plus 1 half. Now we can get a common denominator by multiplying the 1 on the left by 2 over 2. And what we're going to get is 6 halves plus 1 half. Now it's a common denominator. So if I have 6 halves plus 1 half, I'm going to end up with 7 halves. So that's how you would change a mixed number into an improper fraction. That's a long, tedious process. Probably a much easier way to do it. And I'm not sure if you've ever been taught this before, but this is the way I was taught. If I have something like 3.5, what I do is I take and I multiply my denominator times my whole number, and then I add that to the numerator and put it back over the denominator. So in our case, 2 times 3 is 6, plus 1 is 7. Back over the 2 is 7 halves. So that's how we go from a mixed number to an improper fraction. And it's going to be necessary to do that in order to do some of our division and multiplication and things like that. If we have to change it back, the idea is, how many times does my denominator go into my numerator evenly? Well, 2 goes into 7. It doesn't actually go into 7. It goes into 6, though, 3 times. So there are 3 whole 2's that go into 7. And then how many is left over? Well, if 2 times 3 is 6, to get to 7, there's 1 left over. So my leftover is 1 over 2. And that's how you would go back. So again, it's ask yourself, how many times does your denominator go into your numerator, and then whatever's left over is the remaining fraction right there. Okay, so let's do an example using division. This is actually example 8. So if I have 2 1/8 divided by 1 2/3. In order to do the problem, we're going to actually need to change both of those into improper fractions so we can use our division property. So again, the idea, 8 times 2 is 16, plus 1 is 17. So 17/8 divided by 3 times 1 is 3, plus 2 is 5, so 5/3. Now I've got a fraction division problem, which, if you remember, says keep the first one, multiply by the reciprocal of the second one. Okay, 3, 17, and 5 are all prime, and 8 is 2 times 2 times 2. Nothing's going to go away, so we simply multiply across the top. 17 times 3 happens to be 51, and then 8 times 5 we should know is 40. It started off with mixed numbers, so we're going to change it back to mixed numbers. How many times does 40 go into 51 evenly? Well, 40 only goes into 51 one time. But I have 11 left over, right? 40 to 51 is 11 left over, so now I've got a leftover of 11 over 40. So 1 11/40 is the division of 2 1/8 divided by 1 2/3. All right, we can do subtraction the same way, addition the same way. This will be the last example. I apologize, this video is getting quite long, but this was a long section. So 50 1/6 minus 38 1/3. So the first thing I might want to do is I'm going to go ahead and change the fraction part of it to have a common denominator first. That way, when I change these things into into improper fractions, the denominator will already be the same. So I can do that by recognizing that 1/6 and 1/3, the common denominator is 6. I'm going to multiply this one by 2 over 2 to get that 1/6, or to get my sixth. So the 50 and 1/6 will stay the same for now. And that's going to become 38, and it looks like 2 over 6, multiplying the fractions together. Now these are going to be some relatively big numbers, so I don't expect you to necessarily do this in your head, but you could probably work it out on the side of the paper, or this might even be a calculator type problem. But we're going to multiply 6 times 50, which is 300, plus 1, so I get 301 over 6. The next one's a little bit more challenging. 38 times 6. Okay, let's see if I can do that one in my head here. 38 times 6 is going to be 48, carry the 4, 18, so it should be 228, I believe. So this is 228, and then I add the 2, it should be 230 over 6. I really hope I did that right. The subtraction actually won't be that difficult. 301 minus 230 is 71 over 6. And I'm pretty sure that does not reduce, so I have to ask myself, how many times does 6 go into 71 evenly? Well, I know that 6 goes into 66, because that's 11. And that would leave a leftover. 66 to 71 would be a leftover of 5. So we should have 11 and 5/6. All right. That wraps up section 1.3.